So now for problem number 14, let me write this a little bigger for you guys so you guys can see it. Let me turn that on. Oh, got to clear that out. It says y is equal to negative 3 times the absolute value of x minus 9. Now what you guys may not remember is that the absolute value function, when written in this form, this is written in the form ax minus h plus k, where h comma k is, we call it a vertex, but really it's a corner. Okay? Really it's a corner, and I misspelled, I ran out of room there. Okay? So now there's no horizontal shift, because h is the horizontal shift and k is the vertical shift up or down. Alright? 3 is going to be the vertical stretch. So this right here is going to flip it and stretch it horizontally. And then this right here is going to shift it down 9 units. So if I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, that's where my corner is going to be. Now, this is also the slope of the function, right? So remember that your absolute value functions, they make like a V shape. Well, the slope of the V is also based on this A term, okay? So now it's going to flip upside down, and it'll have a slope of negative 3. So what I'm going to do is I'm going to go down 1, 2, 3 over 1, and then it's going to be reflected across the y-axis. So that's kind of what the graph would look like. And I'll verify that on a graphing calculator in a second. But the question says, if the function is not differentiable at any given value x, determine whether the problem is a corner, cusp, vertical tangent, or a discontinuity. So what they're saying is that somewhere on this function there's a problem. You can't differentiate it. Where is the problem? Anybody know? This is a corner. And if you guys remember correctly, we cannot differentiate on the corner because as we approach from this side, what is my slope, positive or negative? So my dy dx is positive. And then almost instantaneously, if we approach from the other side, dy dx is negative. My positive sign, I wrote it on an angle, but it looks like an X, so maybe I should fix that.
Wait, where are you getting these points
Hmm? From our textbook. Remember we did the proof on that?
No, like the points you drew there.
Isn't that one positive, not negative?
Oh yeah, it was positive. Okay. What's that?
Like those points you drew, those 3 points, how do you know to draw those as?
Oh, because this is like the slope. So I know that this point exists on the graph because it has a y-intercept of negative 9. So, and there's no vertical shift, right? So the vertex is h comma k, so it's really going to occur at 0 comma 9. So this is a point on the line. So negative 3 is kind of like the slope of the v lines. So I went down 1, 2, 3 over 1, and then because the absolute value bracket is symmetrical across the line of symmetry, which goes through the vertex.
Wait, why you go down 3 over 1?
Right here. Down 3 over 1, that's like the slope.
So just do that for both sides.
Yeah. Now, truth be told, when you do this on your calculator, when you take the test, Mr. Adams likes to explain everything to you because I feel like the more I explain it, the more you'll remember it, the better you'll do on the AAT exam, and the better you'll do if you guys, some of you guys might still try to take the ECT. Let's graph it, basically, is what we could do. So what I'm going to do is I'm going to come in here, and I'm going to say negative 3, second catalog, second catalog, absolute value of x, close the parentheses, whoops, And then, oh, I should have cleared everything out before I did that. Let's do that again. -3 absolute value of x, come outside, -9, right? Let's graph it. Now, I'm going to have to adjust the window because it's going to be way down here. See it? So let me adjust that window real quick. We'll take that to -15. Okay? And so the question that they asked us was, where is it that it's not differentiable? Well, basically what we could say is because of the corner here, where does this corner occur? When x equals 0. So what we would say is, say, f prime of 0 does not exist because it's a corner. So the absolute value functions, anything that, whenever you see an absolute value function, wherever the corner or vertex occurs, what do we know about it? Not differentiable. That's it. That's all problem number 14 is trying to tell us.